All right, so we're going to start today on page 670, or excuse me, 647. Almost at 674. 647. Okay. Read the problem and do part A. So what do we come up with? What you got?
20% to 25%.
20 to 25%. Do we agree with that? Not a lot of agreement with you, Ben. What you got, Luke?
Should be 5 to 20%.
5 to 20%?
Yeah.
Okay. We agree with 5 to 20% now. We got one nod on that one. Okay, well, let's think about it. Okay, so can I borrow your apple juice for 2 seconds? Okay, so if I've got, make sure I cap on this because I don't want to get any apple juice in my water. Okay, all right, okay, so if I've got 20 milliliters of sulfuric acid in my cup here, right? Okay, and is apple juice is going to represent the 5% stuff, right? Okay, so if I pour that stuff in there, is that concentration going to get bigger? Am I going to get more concentrated in my cup by pouring in a 5%? Why not? Why is it not going to? Why is it going to get diluted and not concentrated? Because what's in the cup already is a higher percent than whatever is, right? Okay, so I can't get any more than 20%. So 20% is my maximum on the one end. Okay. Now let's say that Iz's apple juice is like 1,000,000 milliliters, right? Okay, and I pour that into my cup. 1, that's a really big cup. 2, that's going to be, what's the percentage probably going to be of concentration in that cup then? If we pour a lot of apple juice into my cup, apple juice is 5%. Got a room, if we got an Olympic swimming pool size of 5%, and we pour that into my cup, what's the percentage probably going to be of acid? What? 5%. Okay, so that's my range here of values. So part B here now. Suppose that the 20 milliliters of 20% sulfuric acid solution is mixed with 10 milliliters of 5% sulfuric acid solution. What is the resulting concentration? Okay. Now my question to you is, how do they figure out the concentration of solution? How do you figure out how concentrated a solution is? How do they get this that it's 20% right here? Or how did they get that it's 5% right there? How do we do that in life? In real life, how do we make up a percentage of a solution? What do you got?
How much sulfuric acid you put in and how much salt?
So, amount of acid divided by the total liquid in there, right? Okay, so acid divided by liquid. So we need to find how much acid is in that 20%, that 20 milliliters of solution. So how much acid, if we were to take out all the extra water, how much acid would just be left in that 20% solution?
4 milliliters.
How'd you come up with 4 milliliters?
I divided
20 by 5?
Because 20% is
1/5?
1/5
Okay,
of
all right.
100.
That works for me. So you took 20 times 20%, right? And you switched the 20% into a decimal. You actually switched it into a fraction, which was fine. Okay? And so then you got that there are 4 milliliters of the 20 milliliters is actual acid. Yes? Okay. All right. Now what? Ooh.
Do the same thing with the other.
With the other one? Okay. So how much acid is in the, what do we had, 10 milliliters of 5%. Oops, I almost put 10% there. So how much acid is in that 5% solution? 0.5 milliliters, okay? Because you've got 10 times 0.05, and that's going to equal 0.5 milliliters. Okay? Alright? So, if we mix the two solutions, how much acid do we have in our third beaker? What do you got? We've got 4.5 milliliters of acid. How much total solution is in that third beaker? 30 milliliters, right? Okay. So what's 4.5 divided by 30? That's 0.15. So what concentration is that solution? It's a 15% concentrated solution. Part C. Write and solve an equation to calculate the amount of 5% sulfuric acid solution Keisha added to the resulting, if the resulting solution is 12% sulfuric acid. Okay? Now, I already know that it's going to have to be more than 10 milliliters, correct? Because when I add 10 milliliters of that solution, I'm only down to 15%. I want my new result to be 12%. So I already know my answer has got to be more than 10, right? Okay? So here's how I go about doing this. Okay? In my brain, I'm sitting in the chem lab, and I've got a beaker of 20% solution, and I got a beaker of 5% solution, right? And I'm going to pour them both into a third beaker, correct? Or jug, whatever you want to go with. Okay? So I'm actually going to draw out 3 beakers. Okay? In this first beaker, I've got 20 milliliters of 20% solution. Right? How much 5% solution am I going to be adding? X. Oops. Bad all around. I'm going to add in X milliliters of 5% solution. Right? Okay? So now I'm going to take those two and I'm going to pour them into my third one, right? How much milliliters or how many milliliters are going to be in that one? X plus 20. And we want that one to be of what concentration? 12%. Okay. With me? So let's do acid again. Acid concentration. So the acid over here is going to be 20 milliliters at 0.20% or 0.20 plus, I'm going to have X milliliters at 0.05 concentration. And that's going to equal, over here, I had X plus 20 milliliters, and I want that at a 0.12 concentration. Okay. Now let's do some math. So this one we said was 4. What's this one? What's the middle one? 0.05x. And what's the last one? 0.12x plus what? 2.4. Okay, distributing that into those. Okay. How would you go about solving that now? Ooh. Okay, so subtracting 2.4. And what else did you say? And minus 0.05x. So that's going to give you 1.6, right? Equals 0.07x. So what's x going to equal? What did you say is? 22.85? Which one is it? 8.5 or 8.6? 22, well, let's just make it easy. Let's go 22.857 then. How's that sound? And what is that?
That's the concentration.
That's not the concentration. That's milliliters of 5% solution, right? Okay. Questions on that one? Another great style of problem is a wind or current in this case, okay, problem. Okay. Now, if you've ever gone tubing down, I know they do tubing like down the Wolf River, and they do it in the Apple River over by Minneapolis. You know, they do some tubing, stuff like that. Anybody ever gone tubing? Okay? When you go tubing, what do? Other than sit in a tube? Or you lay on a tube. You get, well, you're not getting pulled, but the current's moving you, right? Okay? You move to the destination. Now, have you ever gone tubing and tried to go upstream? It's possible, but it's not very easy to do, right? because you got to get really moving. Because you got to counteract the current that's pushing. Okay? Right? So when you're going with the current is helping you. Right? And when you're going against the current is pushing you back, right? So it's slowing you down, quote unquote, harming you, okay? Hurting you a little bit, okay? It's not helping, okay? So a river barge travels 140 miles, okay? That's kind of important because that's 140 miles, okay? Which means that round trip, what would the round trip be? 280 miles. Okay? So river barge travels 140 miles from a loading dock to a warehouse to deliver supplies. Then it returns back to the loading dock. The barge travels with the current to the warehouse and against the current from the warehouse. The barge's total travel time is 20 hours. Okay? And it travels in still water, so without having any current, it travels at 15 miles per hour. Okay? All right? So the average speed with the current is helping us here, so that's why it's added to our speed. Okay? When we're coming back, we're going against the current, so what are we going to do with the current? We're going to subtract it, so that's going to be 15 minus x. Okay. Now, have you ever heard of distance equals rate? That's a bad R. Distance equals rate times time. You ever heard that one before? Okay. So if I've got a distance and I've got a rate, I can figure out how much time I traveled, correct? Okay, so how do I figure out how much time it takes me? No. I want to solve for t, right? So I'd solve this equation for t by taking my distance and dividing it by r, right? So what's the time that it took me to go to the warehouse from the loading dock? How far is it? Can't use a calculator, promise. How far is it? 140. What's the speed that we took to get there? So how do I figure out how much time? 140 over 15 plus x. Against the current. Coming back. How far? 140. What was our speed? Now we know that that whole trip took us 20 hours. So what was our average speed for the whole trip? Nope. What is 280 divided by 20? So our average speed was 14 miles per hour. Okay? Now, it would have been, Ben, I think you said 15, right? It would have been 15, just the demon in the back of the room, don't worry about it. It would have been 15 if they would have taken the same amount of time. Okay? But obviously, because the current is helping us get there, that's going to go a lot quicker than coming back when the current is going against us. Okay? So they're not an equal time travel or time frame. Okay? So you are given that the barge travel time is 20 hours. Write an algebraic expression in terms of the number of hours. That's key right there. In terms of the number of hours, that tells me that I am going to be looking at this, because this is my number of hours right in here. So I'm going to make an algebraic expression out of that in terms of the number of hours that the barge travels with the current and the number of hours it travels against the current, that is equal to 20. Well, that's going to be 140 divided by 15 plus x plus the time it takes to get back. 140 divided by 15 minus x. That is the same as 20 hours, because that's the time it took me. This is the time it took me here to get there. This is the time it took me to come back. Altogether, that's equal to 20 hours. So, what we need to calculate now is 140 because that's equal to 20. So what I want you to do now is I want you to find me x. So at some point in time, you should be at that line, depending on how you did it. If you did it common denominators and then got rid of your denominators, you would be there. If you multiplied through every term by the common denominator, you'd be there. Okay? So then that becomes, what's this, 2100? Minus 140x plus 2100 plus 140x equals, that's going to be 20 times 225 minus x squared. So this becomes 4,200 equals, I think that's 4,500 minus 20 x squared. Yes? So this becomes negative 300 equals negative 20 x squared when I subtract off 4,500. So this becomes 15 equals x squared when I divide by negative 20. So this becomes plus or minus the square root of 15 when I take the square root on both sides. Yes? Now, my question to you is, can the river's current ever be negative? No. Okay. So I don't need the negative one. Okay? So that leaves me with just the positive one. And what is the square root of 15? 3.87. And that's in miles per hour. Okay. What I'd like you to do now is, I'd like you to figure out Melinda's refrigerator. Spot check here. So Melinda has decided to replace her old refrigerator, so she goes down to the local refrigerator store and gets one for $2,000. Okay, and then it says when you buy big appliances like this, and especially when they're Energy Star, they'll tell you how much money it's going to cost you to operate it. Okay, how they can figure that out, I don't know, but they usually there's kind of like a guide as to that. Okay. So it's going to cost them $46, or it's going to cost her $46 per year to operate it. Okay? So assume that the refrigerator is reliable and the only cost of ownership is plugging it into the wall and keeping your Gatorades cold and your ice creams frozen. Okay? All right? So after 1 year, how much has that refrigerator, what's the average cost for it? $2,046, because you take the $2,000 that it cost her to buy it, plus 1 year of operating it at $46, and then dividing that by the time frame that we're talking, which is 1 year. So that is $2,046. Okay? Now, not very... It's a lot of money, but she's probably not going to go out and buy a new refrigerator every single year. Okay? So she keeps it for 5 years. Okay? Now, what's the average cost of her owning that one? Luke?
$2,213.
No. Because she spent $2,000 on it, right? And then there was 5 years at $46 a year, right? So that's where you got your $2,230, right? But how many years has she owned it? 5 years. So I got to divide that by 5. So her average cost now of owning that refrigerator per year is $446. Okay. What if she keeps it for 10 years? $2,000 on the purchase, right? Plus 10 years at $46 a year. And that's going to be divided by 10 years. So that's 2,460 divided by 10. So now it's only going to cost her, on average, $246 per year. Right? Okay. Part B. Write an expression to represent her average annual cost of owning the refrigerator for X years. Okay? What do you got, Luke?
2,000 plus 46x divided by x.
2,000 plus 46x divided by x. Okay? Agree with that? $46 a year divided by, or plus the initial cost divided by the years we've owned it, or that she's owned it. Okay? So now it's asking us, when is that cost going to be less than $400? We got a kind of rough estimate right now, right? What's our rough estimate?
10 years.
10 years, says Ben. 5 years? Got to be more than 5 years, right? But less than 10. So somewhere, our answer should be somewhere between 5 and 10. Okay? All right, well, let's figure this out. So that would be, I would say 2,000 plus 46x divided by x equals 400. How do you want to go about solving that one? Nope. We don't do guess and check. How can we solve this one? We can cross multiply. Yep. Okay. So if I cross multiply, I get 2,000 plus 46x equals 400x. How am I going to go about solving that one? Okay, so how am I going to go about solving that one?
Minus 46x.
Subtract 46x. So we get 2,000 equals,
64.
nope, 354x. And what's x equal to? let's call it 65 years. So in 5.65 years, she can buy her TV. What's up, Luke?
Why didn't we do the reciprocal? We made cross multiply.
Because we weren't dividing by a fraction.
Oh.
You know what I mean? This up here was, this is like this being over 1. So then I take that one, okay, and then I multiply that one by that one, okay? Get that box out of there, okay? Okay. Or I could have just multiplied both sides by x to get rid of the one, because there's only one fraction, okay? All right. Did this in the exact same spot yet in the earlier class too. I don't know why it won't let me. Okay. So now question number 2 says, she's curious because Energy Star appliances are a little more expensive because they're cheaper to operate. Okay. So now figure out how much the average cost was for this non-Energy Star one was. So what's that going to be? Initial cost was
1,960. Or
initial cost was 1,900,
yeah.
then plus 60 because oops, she only used it for a year. So it's cheaper after 1 year to get the non-Energy Star one, right? What about after 5 years? Is it still cheaper after 5 years? like $6 a year, right? Still cheaper. Okay. What about after 10? Now the Energy Star's finally taken over, right? So somewhere between 5 and 10 years is where that tipping point where it becomes cheaper to get the Energy Star one.
It's definitely still worth it to get non-certified.
The non-certified one? I've had a refrigerator in my basement for 17 years. You know what I mean? So over the course of that, you know what I mean? Over that course of that lifetime, it's cheaper for me to get the Energy Star one, right?
Yeah.
Okay. So let's figure out where that, so write an average cost of owning that one. So that average cost is going to be 1900 plus 60x divided by x, right? Okay. Part C says, when is that switchover point? When is it more cost effective to get the Energy Star one than the non one? Okay, so that equation was again 2000 plus 46x divided by x equals 1900 plus 60x divided by x. What I'd like you to do now is solve that for x. Do I have to cross multiply? Why not, Ryan? Denominators are already the same, right? Okay, so I could just go right to 2000 plus 46x equals 1900 plus 60x. Then if I subtract 1900 and I subtract 46x, I get 100 equals 14x. So I get is 7.14 years. So after a little bit more than 7 years, it's more cost effective to get the Energy Star appliance. Okay? Now, I handed out to you a CREAM 8.4 worksheet. Okay? I would strongly recommend that you do that worksheet tonight, because tomorrow in class we're going to take a formative at the beginning of class that is all word problems. The formative tomorrow is all word problems. Okay? And then we're going to give you time to work on word problems after that and start reviewing for your chapter test on Friday. Okay? Have a great day.